All right, it's time to go over the Chapter 11 test review, which is review for standards 9C, 11a, 11b, and F2. Our first problem is to calculate the volume and surface area of each of these solids. So let's go ahead and start with the rectangular prism. So the formula for, let's start with volume. The formula for volume is going to be area of the base times the height. Since it's a stack, it's considered a stack of rectangles. So another way to consider this is we have a base shape of a rectangle. What's the formula for the rectangles? You know, so this can be simplified to, a lot of you have heard this volume formula before. The area of a rectangle is length times width, and then we have to multiply that by the height of the shape. So length times width times height. Well, volumes for rectangular prisms are pretty easy. We just need to multiply those three numbers that are given to us. Length is 4, the width is 4, and the height is 3. So volume in this case would be 4 times 4 times 3. Which is 48. 48 meters cubed. Okay, next up is going to be the surface area. Surface area is, of course, the area of all surfaces. Since we have a rectangular based prism, we're going to have to figure out the area of each of those sides. There are 6 total faces, so we're going to figure out the area of these 6 faces. So we're going to say surface area is going to be 2 of these guys plus 2 of these guys right there, plus 2 of these guys, which is the yellow ones that I have there. I'll go ahead and just kind of draw what it looks like. This is going to help me organize what my surface area is going to be. So the surface area of 2 of these front faces is going to be 2 times a 4 by 3. This is a 4 by 3. We also have 2 faces of, well, also a 4 by 3. Interesting. And then also we have on the top and bottom here, we have 2 4x4s, which we have in the yellow. So if we had to color code each one, you know, we can definitely do that here. But it is difficult since it is a 3D figure. So that gives us 2 times 12, the area of those 2 figures, those 2 shapes, plus 2 times 12, plus 2 times 16. So if I multiply all this together, it actually, you know, you can just combine like terms if you want to. 2 times 12 plus 16. But however you do this, you're ultimately going to get the same answer of the surface area is equal to, let's see, 24 plus 24 plus 32.
That would be 80.
So 80 meters squared. Surface area is no fun. It can be very tedious sometimes. So of the 2 problems, which you think was easier, volume or surface area? All right. You can kind of tell visually which one was more difficult. All right, moving on to the next problem, number 2. Volume is the same formula for this stack as well. This whole entire standard 11a is all about this formula right here. It's the base area, or area of the base, times the height. Okay, so the area of the base. To be able to calculate the area of the base shape, we're going to need to figure out the area of a triangle. This makes triangular base prisms pretty difficult sometimes. So we need to find out the area of a triangle. What kind of triangle is this? Is this the right triangle? Or is it just a triangle? Okay, so as you can see, the area of this shape would be half base times height. We got to use the area of a triangle. So we're figuring out the area of the triangle and multiplying that by the height. Or in this case, we can also call it the length of the shape, which I can label right here as 10. Okay, so let's figure out what the area of the triangle is. I know that it's going to be 1/2. What's the base of that triangle? Look at this. We're only given 15 as the hypotenuse. We're giving 12 as the leg. We're missing the base, the length of that triangle right there. We're actually missing that. We need that to figure out the area of that triangle. So what we need to do is use the Pythagorean theorem to figure out the length or the width or the base of that triangle. So I'm going to go ahead and say that this is, let's call this A. A squared plus 12 squared is equal to our hypotenuse squared, which is 15. Solving, you should get an answer of 9. There's two reasons why I should be able to do this quickly. Is I can do 15 squared minus 12 squared in my calculator pretty quickly. But ultimately, I should also, or could also remember that this is a 9, 12, 15 right triangle. Or it's a 3, 4, 5 multiplied by 3. This is a special right triangle right there. So we know the base of this shape has to be 9. Look, that's what makes these triangle base prisms pretty difficult. So we have the base area is going to be half of 9 times 12. That's the area of that triangle. The base shape. Now we got to multiply it by the height. The height, not of the height of the triangle, but the height of the stack. Remember that word stack. How high is this stack? The height or length of that figure. So I need to multiply that by 10. Okay, now multiplying these four numbers together, I will get my final answer. Okay, let's multiply. 1/2 times 9 times 12 times 10.
It's 540.
The answer would be 540 centimeters cubed. Okay, now for surface area, we're going to go ahead and have to calculate the area of two base triangles shown there. And we're also going to have to figure out the area of the remaining figures. So if you can see here, we do have a rectangle on the right side, sort of like that. We also have a rectangle here on the left side visually of that shape. And we also have a rectangle there in the back. So that's going to be, the area is going to be of not only two triangles on the top and bottom, but the three rectangles around it. So I'm going to go ahead and organize my work like this. Okay, we just calculated the area of two triangles. Actually, I kind of missed it here, but it's going to be 2 times 1/2 times 9 times 12. Remember the area of those two triangles is right there. We also have for this this shaped rectangle right here, we have a 9 by 10. For this rectangle right there on the front facing left part of our triangle, your triangular base prism, we have a 12 by, what's this length, right? 10, right? 10. A 12 by 10. And for our last rectangle in the back there, we do have a 10 by 15. So I'll put that right there, 10 by 15. Okay, so I'm going to add up all these surface areas to get my final total surface area. That's why, of course, surface area is very difficult. You'll probably only have 1 or 2 surface area questions, as they are very challenging. Although we're not denying a challenge, but we do want to give you a chance to finish your tests, right? So let's multiply all this together. We'll just say 2 times a half is a whole, and then I'll multiply everything here. 9 plus, oh, let me try that again. 9 times 12 plus 9 times 10 plus 12 times 10 plus 10 times 15.
It's 468.
So we get our final answer of 468 centimeters squared. That's for the triangular based prism. All right, now we're going to move on to this shape right here. What kind of shape is this? Let's see. This one's going to be a cylinder. So it's going to be the same formula here as well. Volume equals area of the base, capital B, times the height. Now, the area of the base, we know, is got a formula of, well, what shape is that right there? Of course, it's a circle. So we know the area of the circle is pi r squared. And the height I know the height of the stack is h, which is 2. So all we really need is the radius and the height. So we're going to go ahead and multiply pi times the radius appears to be 5 meters squared, and multiply that by the height. The height is 2. So multiplying all this together, I'm going to write my answer as an exact answer. Check this out. Pi times 5 squared. 5 squared is 25. 25 times 2 is going to be 50. 50 pi. This is called my exact answer. Fifty pi meters cubed. That's our called our exact answer. Now, what is that as a decimal? You can either do 50 times 3.14, or in your calculator, find the pi button. The pi button in my calculator happens to be right there. Pi. But I'll use Siri for this one. What is 50 times pi?
The answer is approximately 157.0796.
157.0796, so approximately 0.8 meters cubed. Either of these two answers is wonderful. Sometimes you're going to get a question ask you for the exact answer, while other times you might get a question that asks you for the approximate answer. So if it does ask you that type of question, then be sure to write either your answer as exact, where it's equal to, where you don't round pi, or you write your answer as a decimal, where you need to multiply by pi. Okay? Next up is the surface area. So for surface area of a cylinder, we're actually going to have 2 circles and a rectangle that wraps around that figure. Have you seen a can before? A can's wrapper, or like the water bottles, you know. What's wrapped around it is a rectangle. So I'm going to show you some formulas, and we're going to make sense of them. The first formula that we have here shows that we can take a cylinder and get two circles out of it and the rectangle that goes around it. It gives us this really complicated version of the formula, which is 2 pi RH, using the circumference, and 2 pi r squared, which is the volume of two circles, or sorry, area of two circles. So again, you can think about it as two circles, which is 2 pi r squared, and then you can think about it as the rectangle that wraps around it. But what's really great is we can break this into a very simple formula. And this is the formula that we're just going to use for surface area if needed. Okay, so I'm going to write that formula down here. Surface area equals 2 pi r times r plus h. That's the simplified version of this guy, where you take the common factors of 2 pi and r, and then you factor it out of that formula. But yeah, for that sake, we're just going to use this version of the formula because it's a lot easier to look at visually. Okay, so for this example, we have that the radius is 5. And then here we have to do the radius plus the height. The radius is 5, the height is 2. Now look how easy this is. Once you use the formula, as long as you know what r and h are, you just have to multiply those numbers. So we're going to get 10 times pi times 7, which, as an exact answer, we get 70 pi, or as an approximate answer, what is 70 times pi? Let's ask Siri. What is 70 times pi?
It's approximately 219.9114.
219.91 meters squared. Remember, this is the surface area. So area is units squared, while volume is units cubed. Okay, let's move on to the next one here, which is the volume of a, wow, this is a tough one, a regular 1, 2, 3, 4, 5, 6 hexagonal based prism. Now remember, these volume formulas, as long as it's a stack, it's a very simple formula. Area of the base times the height. So let's see where this problem takes us. Okay, we have to find the area of the base. I'll color it in orange here. And we need to multiply that by the height of the stack. Okay. So the area of the base is 1/2 perimeter apothem. Do you remember that formula? It may be a formula used. Otherwise, you have to find the area of a regular hexagon in a different way, depending on how you learned it. But we're going to use this formula for the area of the hexagon, the regular hexagon, and that is multiplied again by h. So check it out. It's kind of a strange formula for volume, but as long as we use the basic formula for stacks, we can figure out the volume. Area of the base times the height. So if you don't know the area of the base shape, you can't really find the volume. But let's calculate it since we do know how to do this. All right. So P stands for the perimeter. I guess I could write that down, huh? P stands for the perimeter. So the perimeter appears to be 4 plus 4 plus 4 plus 4 plus 4 plus 4. 4 times 6, so that's going to be 24. And A stands for the apothem, which is given to us. The A is the apothem there. The apothem is given to us as 2 root 3. While the height of the figure, the stack, is going to be 8. We need to multiply these numbers out. Good news. We can write our answer as exact. What is 1/2 times 24 times 2 root 3 times 8? So half of 24 is 12. 12 times 2 is 24. And 24 times 8.
It's 192.
We get 192 root 3. What is 192 times root 3?
Here's what I found.
What is 192 times the square root of 3?
The answer is approximately 332.5537.
So we get our final answer of 332.55 centimeters cubed. Either of those two answers is great. The exact answer or the approximate answer. Okay. Area of the base times the height. Okay, next up is the surface area of that figure. The surface area of this figure is going to be 2 regular hexagons. And it's also going to be 6 rectangles. Remember, these rectangles are the same length and width all the way around the shape. So we have all these rectangles here. They are all the same. They're all the same rectangle. So we need to multiply the number 2 by the area of the base. The base area, we kind of figured it out here. It's 1/2 PA, perimeter, apothem, and the height. Sorry about that. So it's going to be 2 times 1/2 times 24 times 2 root 3. Whatever that is. We didn't actually do that individual calculation yet. Plus 6 times the rectangles. The rectangle's length and width, if we look at this shape right here, it's going to be a 4 by 8. A 4 by 8. 4 by 8 rectangles. So adding those up, we're going to get our answer. Okay, same as before, we can cancel those out. 24 times 2 root 3. Our calculator gives us 41.56, approximately 41.57. 6 times 4 times 8. We get 192. So we have to add up the area of the 2 regular hexagons and also the 6 rectangles. 192 plus 41.57.
That would be 233.57.
So we get our answer of 233.57 centimeters squared. That's our approximate answer. Okay, for the next one, we're going to go ahead and answer some questions about volume and probably also some areas as well. Number 5, prism A and prism B are similar with a ratio of similarity of 2 to 3. By the way, 2 to 3 is also 1.5. Why? What's 3 divided by 2?
It's 1.5.
So you can say it's 1.5 times bigger if you want to figure it out that way. The second sentence says, if the volume of prism A, not prison, if the volume of prism, if the volume of prism if the volume of prism A is 36 cubic units, what's the volume of prism B? Okay, so we know that R is scale factor. R squared is area ratio. And R cubed, this is the one we need, is the volume ratio. Volume grows really, really rapidly. So if the scale factor is 2 to 3, or 3 over 2, 2/3, whatever way you want to say it, then the volume is going to be cubed of that. So it's not going to be 2 to 3 cubed to 3 cubed. Now what's 2 cubed? 2 times 2 times 2, it's 8. 3 cubed is 3 times 3 times 3, which is 27. That means this is our volume ratio. So that means we are going to have to multiply this guy by either 27 over 8 or 8 over 27. Now, is figure A smaller or bigger? Let's see. From figure A to figure B, it's 2 to 3. So B is bigger. We're going to need to multiply by the bigger fraction. 36 multiplied by 27 over 8 is going to give us our answer. Now, you can also figure this out as a ratio. You can say 27 over 8 is B over A. We know A is 36, so you could figure out the volume of figure B if you just input the volume given us for A. It says 36 is the volume for A, so we can figure it out this way. You would still need to multiply by 27 over 8, right? If you cross multiply or multiply by 36, you'll still get the same step that we're here. Okay, so 37 times 27 divided by 8.
The answer is 124.875.
So the volume of figure B is 124.875 units cubed. We can check our work, right? The answers are on the back. So if we check our work, the answer should be, it says 121.5. Where's our mistake? I need to try this calculation again. Let's see. 36 times 27 divided by 8.
It's 121.5.
So calculator error. So the answer should not be this number that my calculator gave me earlier, but it should be, let's recalculate it, 36 times 27 divided by 8.
The answer is 20.25.
Okay, let's try it again. 36 divided by 27 divided by 8. Okay. 36 times 27 divided by 8.
The answer is 121.5.
There we go. So 121.5 units cubed should be the correct answer. Let's move on to the next one. The two prisms are similar and the ratio of their areas, this is kind of weird because we're going to be talking about not the scale factor, but the areas. Okay, the ratio of their areas is 16 to 1. If the volume of the smaller figure is 15 meters cubed, what's the volume of the larger figure? So we got to work backwards in a way. The scale factor is R. R squared is the area ratio, which we know is times 16. 16 to 1. And the volume ratio is R cubed. That's the ratio that we need. So we need to work backwards. If the ratio squared is 16, we know that the scale factor is the square root of that. So we'll get our answer of 4. 4 times bigger. That's the scale factor. Now, if the scale factor is 4, how do we get to our volume ratio? So our volume ratio is cube of that. 4 cubed is, I want to say 216, but I'm not sure. 4 cubed.
The answer is 64.
Oh, I was way off. I was super off. So the volume ratio is going to be 64 times bigger. Now I have a trick for you. There is a trick. If you're ever going from area ratio to volume ratio, you could just do 16, for example, 16 to the 3/2 power. What is 16 to the 3/2 power?
The answer is 64.
So if you wanted to go straight from area ratio to volume ratio, you could do 3/2 power, but maybe it's just better to do it this way. So let's finish the question. The volume is going to be 64 times bigger. So if the volume of the smaller figure is 15, then the volume of the bigger figure is 15 times 64. 64 times 15.
It's 960.
Our answer is going to be volume of the bigger figure is 960 meters cubed using the volume ratio. Okay, number 7. The ratio of the volumes of two similar cylinders is 27 to 64. Okay, we're given the volume ratio. We're going to say 27 to 64. It says, what is the ratio of the diameters? Okay, diameters is the same as scale factor, right? So we need to find R. R is the ratio of the sides. So we do not need the area ratio. We need the ratio, the scale factor. Okay, so if it's 27 to 64, how do you go from cube all the way back to R? Yes, you're going to have to do the cube root of those numbers. So it's going to be the cube root of 27.
It's 3.
Which is 3. And the cube root of 64. Cube root of 64
It's 4.
is 4. So our final answer is the ratio of the diameters would be 3 to 4. Keep in mind these ratios that can always be written as 3/4 or 4/3 depending on how you want to write it. Even you learned this earlier in your earlier grades, you could write ratios as 3 to 4. But since it's written this way, we should probably write our final answer as 3 to 4. Now, just a quick way to double check your answer. Is this number cubed 27? 3 cubed.
That would be 27.
Good. And is this number cubed 64? 4 cubed.
The answer is 64.
So that's a great way to check our answer. That wraps up standard 11A. Our next standard is going to be 11B. Can we find the surface area and volume of cones, pyramids, and also spheres? Now keep in mind, cones and pyramids, we need to remember that they have something called an apex. Apex. And also right here, apex. If it has an apex, we should remember the volume is, well, something that's an apex. It's going to be 1/3. 1/3 the area of the base vertical height. Okay, so let's use those formulas to calculate the volumes of these shapes, and also a little bit of surface area practice as well. So number 8, the figure shown at right, or rightus, is a square-based pyramid. Calculate its surface area and also its volume. So we're going to start off by calculating the volume. Volume equals 1/3. Area of the base. What is the area of a base shaped like a square? Yes, length times width times height. So if you wanted to, you can consider this one as length times width times, finally, the height. 1/3 length width height. So that's going to give us the answer of 1/3. The length and width happens to be 7 by 7, which is the base area is 49. And the height is, vertical height is given as 9. Let's multiply these three numbers. 1/3 times 49 times 9. The answer is going to be 146.999. Is that true? Let's try again. 49 times 9 divided by 3.
That would be 147.
Ah, there we go. Now that's more like it. The answer is going to be 147 centimeters cubed. Okay, next up is going to be the surface area of this figure. The surface area of this type of pyramid is going to be 1 square, which is the base shape, plus we have 4 triangles that go around that shape. So I'm going to label this as 4 triangles. So let's start off with the easy part. The area of that base shape is 49, since it's length times width. 7 times 7, 49. And then the area of one triangle. Okay, we need to locate this triangle. So the triangle is, let's use, which triangle should we use? They're all the same triangle, but I'm going to use this triangle right here as reference. Okay, so we need to have the 1/2 times the base times the height of that triangle. Now we need to remember that the height of the triangle is going to be going straight up that triangle right there. So we need to find not the vertical height, but the slant height of that figure. So I'm going to zoom in one more time, just a little bit closer there. The height of this triangle actually needs to go straight up that triangle. So we need to figure out what this slant height is right there. So looking at this triangle, it's the shaded one right there. We need to figure out the height. The base we know is entirely 7, but the height of that triangle is not 9. 9 is this height. So the way that we figure this out is we need to figure out the height by creating a right triangle. I'll draw that right triangle right here. This one right there. Now, the height of that entire shape is 9. What's that length right there? The length right there would be 1/2 of 7, 3.5. And the hypotenuse, we need to figure that out. And I'll just call that L, the slant height. So calculating it, we got to use the Pythagorean theorem. 3.5 squared plus 9 squared is equal to L squared. .5 squared.
The answer is 12.25.
Okay, let me just use the calculator all at once. 3.5 squared plus 9 squared.
The answer is 93.25.
What is the square root of 93.25?
It's approximately 9.6566.
So 9.6566, so 9.66 approximately. I can include more decimal places there, but I know my answer is going to be relatively close using this. So the height of this triangle, I know this question is difficult. The height of this triangle right there, the same as the height of this triangle, the height of that triangle there, is going to be 9.6686 or something like that. Okay, so going back to our surface area, we have one square, we have four triangles. The triangles have a base of 7 and a height of 9.66. So if you thought that the height was 9, the height of each of these triangles is actually considered the slant height. Sometimes it's given to you. Sometimes it's not. 4 times a half times 7 times 9.66.
It's 135.24.
135.24 plus 49.
It's 184.24.
So we get an approximate answer of 184.24 centimeters squared. Moving on. What's the total surface area and volume of the cone shown at right? Okay, we're going to use the volume of the cone formula. It's going to be 1/3 the base area times the height. Okay, so we can simplify this to be, we know that it's 1/3. The area of a circle is pi r squared. And the height of this shape is, we can just label it as h for now. This is the area, or sorry, the volume of all cylinders. But let's plug in some numbers now. We get 1/3 pi, the radius is 5, and the height of this figure is 12. I'll use some color, there we go. Okay, that gives us 1/3 pi times 25 times 12. 12 divided by 3 is 4. 4 times 25 is 100. We can leave our answer as 100 pi, or we can put this into our calculator and get our final answer of approximately 314. What's 100 times pi?
It's approximately 314.1592.
So 159 adds up to about 314.16. We'll call this feet cubed. Either of these answers is great. It is the exact answer, 100 pi, or the approximate answer, 314.16. Okay, next up is surface area. Surface area of a cone. Surface area of a cone is pretty complicated because when you break up the surface area of a cone, you're going to have a circle, and you're also going to have a sector. Like if you've ever opened up a party hat, the party hat is shaped like a sector. So a cone, which is a party hat, opens up to be a sector. So there is a formula for this that we're going to use. It's going to be pi r squared plus pi r L, where L is the slant height. Using our formula, we're going to get pi times 5 squared plus pi times 5 times the slant height. Uh-oh, we need the slant height. The slant height is a 5, 12, 13. So 5 squared plus 12 squared equals 13 squared. We can go ahead and figure out the slant height is 13. Pythagorean theorem. Now keep in mind you could use a different formula. There is another formula, pi times r plus L. If you wanted to use it that way, there's another way to do it as well. We're going to go ahead and use this formula right here, which is on the posters, hopefully in your classroom. So the answer will be 25 pi plus 13 times 5.
That would be 65.
65 pi. So I just multiplied 5 squared times pi, 25. 5 times 13 is 65, 65 pi. 65 plus 25.
It's 90.
Our final answer, as exact, is 90 pi feet squared. 90 times pi.
The answer is approximately 282.7433.
So 282.74 feet squared. Remember, you can just write your answer as approximate unless it's also asking for your exact answer. But most of the time, you can just write your answer as approximate. Okay, the next one is number 10, the surface area and volume of a sphere. So, volume of a sphere, it's got a pretty simple formula, kind of intense though. It is 4/3 pi r cubed. And then the surface area of a sphere is 4 pi r squared. So notice for these two formulas, all you do need is one thing, which is the radius. So since we're given the radius is 12, let's just input the number 12 into each of these formulas. 4/3 pi 12 cubed and 4 pi 12 squared. Those are the two formulas that you can find on posters or hopefully in the math notes to get the surface area and volume of a sphere. So I'm going to input these numbers into my calculator and I'm going to get my answers pretty quickly. Using parentheses, I'll get 4/3 times pi, which is right there. Pi. Right there, sorry. Times 12 cubed. That gives me approximately 7238.23 centimeters cubed. And if I use the second for surface area, I will get surface area is 4 times pi times 12 squared. I know that's 144, but I'll just enter 12 squared. And that gives me the surface area is approximately 1809.56 centimeters squared. Bunch of practice problems going on here. Okay, the next one is number 11. The base of the pyramid shown at right is a regular hexagon and the height is 14. The height goes down to the center inches. Calculate the volume and surface area of the pyramid. So for number 11, the volume is going to be, remember, if it's got an apex, it's going to be 1/3 the area of the base times the height, the vertical height. I'm sorry about that. So we have a much more complicated formula now that's going to be 1/3 area of a regular hexagon is 1/2 perimeter apothem if you use that formula. And then times the height, which is, we know it's 14. So let's calculate these things. One-third times a half times the perimeter. The perimeter happens to be 8 times 6, which is 48. And the apothem is not given to us. So we need to figure out what the apothem is. The apothem is this length, otherwise known as this length. So we're going to figure out the apothem by dividing this regular hexagon into triangles. So dividing 360 divided by 6, we're going to get 60 degrees. Cutting that in half, we're going to get a triangle that is going to be 30 degrees. Now, remember, we're looking at this triangle right there. The central angle is 30 degrees. The length of the side here is half of 8, which is 4. And the apothem is A. You can use trigonometry to figure out what the apothem is. I would also recommend you use 30, 60, 90s since this is a special triangle. Remember, 30, 60, 90s use 1√32. So we know that the answer right away is going to be 4√3 if you use special right triangles. But you can also use tangent. Tangent of 30 degrees equals 4 over A. So A is equal to the tangent, A is equal to 4 divided by the tangent of 30. Four divided by the tangent of 30 is 6.9282, so 6.93 about. And also, you can check 4 times √3 would give you the same answer. So either of those methods to find the apothem would give you 6.93 about. Okay, so we have the apothem is 6.93, and the height of the figure is 14 inches. So multiplying all these numbers together, I will get my answer. What is, let me try this with Siri. What is 1/3 times 1/2 times 8 times 6 times 6.93 times 14?
It's approximately 776.1599.
So the volume here would be 776.16 about, and that's inches cubed. I can write that again, 776.16 inches cubed. Okay, next up is the surface area of this shape. For the surface area, we do have our regular hexagon, and we also have 6 triangles. For the triangles, remember we need the slant height. We need to figure out what the slant height is to figure out the triangle. So there's multiple issues we have going on here, but we're going to be able to solve it. So the surface area of the hexagon was 1/2. We did it right here. That was the surface area of the hexagon. One-half times 8 times 6 times 6.93.
The answer is 166.32.
So the area of one hexagon was 166.32. And the area of 6 triangles would, let's figure out the area of this one triangle right here. The area of the one triangle, it looks like this. It's a base of 8 and a height of unknown. Remember, it's not the vertical height, but the slant height. So we need to figure out what the slant height is. We do this by the Pythagorean theorem. So to figure out the height here, we need to create a right triangle. Half of it is 4. So I'll draw it right here, actually. Half of it is 4. The height is 14, and the slant height is right there. So I made a mistake right here. The length of this triangle is not actually 4. It's not half. This is actually the apothem. So the apothem is 6.93. Remember when we calculated it here? The apothem is 6.93. This is what makes hexagonal-based pyramids one of the most difficult questions, if you're not given the measurements needed. So calculating the Pythagorean theorem, we're going to get 14 squared plus 6.93 squared equals our slant squared. This gives us 14 squared plus 6.93 squared.
It's approximately 244.0248.
And if I square root those, square root of 244.02.
That would be approximately 15.6211.
So we get that the base of this shape, or sorry, this slant height, we get that the slant height right there, L, which is the height of the shape, is going to be 15.62. So the height of this shape, which is the slant height here, is 15.62. So that gives us 6 triangles. Half of 8 times 15.62 gives us our surface area. 6 times a half times 8 times 15.62.
It's 374.88.
So 374.88. 374.88 plus 166.32.
The answer is 541.2.
And remember, surface area 541.2 approximately, or squared, inches squared. The surface area of the larger figure is, again, making this the most difficult questions if we're not given the measurements and we have to solve. Then what is the surface area of the smaller cone? So we know the bigger surface area is 80 pi. What's the area of the smaller cone? So we need to figure out the ratio of the areas. The scale factor is what? If the volumes are 8 times bigger, the scale factor has to be the cube root of that. So cube root of 8 is 2 to 1. And therefore the area ratio would be 4 to 1. We know the area has to be 4 times bigger. So if we divide by 4, we're going to get our answer. Remember, volume ratio is cubed, area ratio is squared, so we can work backwards by taking the cube root, work forward by squaring, and we get that the areas are 4 times smaller. So therefore, 80 divided by 4 gives us our final answer of 20 pi meters squared. And that's it. Standard 11a and 11b.